Okay, so the trapezium rule, it's a method of approximating integration for a curve that you might not necessarily know the equation for, so you can use the trapezium rule instead of integrating to find a good approximation of the area. And it's kind of similar to binomial expansion in the sense that you're given a long formula in the formula booklet and you've got to plug numbers into it to try and get a value out at the end. But a good understanding and being able to derive it is useful as well. So if we take a curve that looks like this, and we want to integrate it between the points B and A, then we split it up. It has an intersection point of y0, and we split it up into an n number of segments of delta x. So they have width delta x, and then they carry up to here. I'm going to have to apologise quickly because the notation's quite bad. This a and b isn't the same as this a and b, and this h isn't actually the height of the equation. What this is it's the area of a trapezium. So if you have a trapezium of length a at the top, length b at the bottom, and a height h, then that gives the equation of that trapezium. The equation for the area of that trapezium. And we're splitting our area up into different trapeziums, so they have length A here, length B here, and a height delta h. So delta h is equivalent to h. So they have length here, A equals y0, length here, B equals y1, and height delta h. And the same for this one, height distance y1, distance y2, height delta h, and then each of them trapeziums you can find the area of. So for integration we're finding the area under a curve, so to find this whole area under this curve we add up all the areas of the trapeziums together. So that's our first one here, and we've got our second one, our third one, our fourth one, all the way up to the nth one. So we're doing h, which is our delta x, times y0 plus y1 over 2, plus delta x, or h, y1 plus y2 over 2, and carry that all the way up. Now if we take out a factor of h, then we take out a factor of h, and we're going to have y0 over 2 plus y1 over 2, plus y1 over 2, plus y2 over 2, plus y2 over 2, plus y3 over 2, all the way up to plus yn minus 1 over 2, plus yn minus 1 over 2, plus yn over 2. So everything is over 2 added by itself, except the y0 and the yn, which don't have itself to add to. So they stay as y0 and yn over 2, whereas everything else, the y1 over the 2 plus y1 over 2, just becomes y1. So this here is approximately equal to this equation. So you have half times h, so we take out a factor of a half, and then we've got y0 plus yn, and then everything else added together times by 2. And finally, we can treat h as because we're integrating between b and a, so we've got b this side and a this side, and we're treating it as n number of trapeziums, then h is just the distance b minus a divided by n, because b minus a divided by n is just equivalent to each of these delta x's if it's split up into n number of delta x's. So to integrate between b and a, then what you want to do is b minus a over 2 times the number of trapeziums that you're using for your integration, and then times by this whole thing here. So the more number of trapeziums you have, obviously the more accurate your integration is going to get, but the trapezium will be an approximation, so you're not going to get an exact answer. Sometimes in the exam it'll tell you to do it via the trapezium rule, and then tell you to integrate it properly. The trapezium rule will just be an approximation, so they won't be exactly the same, but if they're similar, then you can tell that you've got the right answer. So remember, ask any questions if you've got anything, and like and subscribe for the videos on my channel.